Hey there, in this video we are introducing while loops, and this covers sections 5.1 and 5.2 in the Gaddis C++ book. Now we've said previously, what are loops? They are how you get a computer to repeat a certain task in a computing system. In this chapter we're actually going to see 3 different looping structures to get repetitions to happen. I should tell you about this very famous computer scientist named Alan Perlis. And Alan Perlis was actually the first ever winner of the Turing Award, which a lot of people refer to as the Nobel Prize of Computing, first ever winner. And he wrote this very influential book called Epigrams in Programming. And along the way in that book, he wrote this. He wrote, "A program without a loop isn't worth writing." And he's pretty much right about that, actually. So using loops, it really unlocks the potential for your computer processor to run at full speed and use those processor cycles to do a whole bunch of work very, very quickly for you. So I think that's what Alan Perlis meant by that. And here in chapter 5, we finally get to use loops, and we finally get to write programs that are worth writing. All right, so let's think about the basic idea of a loop if it's not clear already. A loop is going to be a sequence of statements that can be repeated 1 or more times. Very easy to get it to repeat it 2 or 3 or 4 or 5 times, or 10 or 100 or 1,000, or why not 1,000,000 times, right? It's no extra work on the programmer's end. And how that winds up actually happening in the code is that it does some statements, and the control is going to jump back up to an earlier statement and then just go on again the same way that it did before. Let's look at that in flowchart form. So basic idea of a loop here, a program starts at the top, it runs some statements like A, and then it gets to a decision point. Remember, the diamond is a decision point, that decision B there, where you check in on a Boolean. And the Boolean is either true or false. If that Boolean is true, then you're going to go on with these statements, maybe D and C, and then the key thing is that you go back to B. And you check in on that Boolean again. If it's still true, you'll do D and you'll do C like normal, and then you'll go back to B again. So you can kind of see visually, that's why we call this a loop, because you actually get a visual circuit in the flowchart, which is where that comes from. So that'll repeat and happen again and happen again and happen again. Now, hopefully at some point something changes which makes the Boolean become false. At that point, you get back to that decision at B, that becomes false, and then you skip over these statements D and C, and you go on with the rest of the program and end the program at some point. So that's the basic idea of a loop. We'll have 3 different ways of actually making that happen, and that is what chapter 5 is about. Now, before we get into that, before we actually see our first loop, there's a little piece of technology that we use a lot in conjunction with loops that you should know about, so let's just check in on that first. And these are the increment and decrement operators. So increment means to add 1 to a variable, and decrement means to subtract 1 from a variable. Just modify it by 1 single unit. That's very, very common, and adding or subtracting 1 from a variable is so common that it has its own little syntax so that we can type it very, very quickly. The increment operator is plus, is 2 plus symbols right next to a variable. So you can write plus val, or you could write val plus, right? I'm assuming that val is a variable that you've declared previously, and either one of those is going to add 1 to your variable val. It'll become 1 bigger. And then the decrement operator is 2 minus signs right after another, minus. So you can write minus your variable, you can write your variable minus, and either way, it's going to subtract 1 and make your variable 1 pip lower, 1 unit lower. Okay, so pretty simple. Now, there is this fine print on the increment decrement operators that you need to be aware of to be fully sure about what's really happening. And that's the 2 variations, right? Whether you type the symbol before the variable or after the symbol changes where it happens in the order of operations. Okay, so the 2 variations indicate the order of operations of where this operation happens as compared to all the other operations in the same statement. So if you put the symbol before your variable, that's called prefix notation, and that says, I want this to be the very first thing in this statement before any other operations. If I have this in a statement that also has plus and minus and times and divide and whatever, this increment decrement will be the very first thing, and then you'll go do all the other stuff, the plus and the times and the minus and the divide, okay? But on the other hand, if you put the increment decrement operator right after the variable, that's called postfix notation, and that's indicating that you want that operation to be the very last thing in that statement, after everything else, after any sins or counts or adds or subtracts or times or divides or anything, the very last thing. So you get to pick whether you want this increment decrement to be the very first thing or the very last thing, and that's indicated by whether you used prefix or postfix notation. Now, so as professional programmers, we like our code to be short. Again, we like as many operations on screen visibly as possible. We want our code to not take up very much space. So for me, it's pretty common to write a piece of math that has a bunch of operations, including increment decrement, and I'm going to be very careful about whether I use prefix or postfix notation for whether I want it to happen first or last. That can be a little tricky if you're a beginning programmer. So if you put the increment decrement on its own line as just one single statement, then frankly, it doesn't matter whether you use prefix or postfix because it'll be the only operation on that line. So if you want to be safe as a beginning programmer, go ahead and put the increment decrement operator in one single statement, right? And then you won't run into this kind of tricky issue. But you should be aware of it. You should be aware of the difference. It makes for a good test question. In my classes on the next test, I'm sure there'll be one or two questions about prefix postfix difference, so you're aware of it. And of course, as you go forward in programming in later classes, it'll be more and more important that you're aware of that. I should say that the increment operator plus to add one thing to something, that's where you get the name of the language, right? The name of the language C++ is sort of an inside joke. That it says we took the C language that came before it and we added one thing to it, namely object-oriented programming. Now, that's actually an issue that we don't get into until second semester programming at our school, but that is actually what C++, the name of the language, actually means. We took C, added one thing to it, haha. Okay, a lot of naming stuff in computing happens to be kind of sort of inside jokes, so now you understand where the name came from. Okay, so let's review that. Increment, decrement. Obviously, plus adds one, decrement minus subtracts one, but the tricky thing is to pay attention to the prefix postfix order of operations. So here's kind of a quiz slide on that. You're going to see some expressions. You're going to see the variable val, and on every single line, we'll assume that val is holding 12. Okay, so here's some statements, right? So it could be some assignments, could be some count statements that have the increment decrement operator in there. And we're going to ask, what is the effect of this? Now, there's going to be at least two different things happening, right? Each of these statements has two different things happening. So the question is, what does the statement do normally? And then in addition, what does the variable become? Okay, and these are two separate things. So let's think about that very first one. Okay, so I see a count statement and I see val with plus after it. Now, after it means postfix notation. So the plus is going to be the very last thing that happens here after the count insertion. So the count insertion happens first, and you wind up printing a 12 to the console. Once that's over, then you increment val, and then val becomes 13. Okay, so you've printed 12, but now what you have in memory in the variable is the number 13. You see the difference there? So if you understand what we said about prefix postfix notation, maybe pause the video and see if you can indicate what gets printed, what gets assigned to num, right, in the last two here, and then in addition, what is val after the statement. And if you think you have the answers, restart the video and we'll see if we agree. Okay, hopefully you figured that out. So for the second one, very similar to the first, but here the increment is in prefix notation, so it's the very first thing that's going to happen. So obviously val becomes 13, and then the count insertion happens, and you wind up printing that. You wind up printing 13, right? Pretty significant difference. In the first one, you printed 12, and the second one, you printed 13. Now, either way you slice it, the variable val now has 13, obviously, but you printed two different things depending on the prefix postfix. So for the third one, now I see assignment, something's getting assigned to the variable num, and decrement. What happens first? So the decrement is in prefix notation. So if val starts at 12, it becomes 11, and then you assign that into num, and I guess num gets 11. Okay, so val becomes 11, and then num gets that assigned 11. In the last one, the decrement there is in postfix notation. It's going to be the very last thing that happens. So first of all, assignment happens, and num gets the 12 that's in val to begin with. Num gets 12, and then after that, val becomes 11. Okay, so again, the last two pretty similar, right? We know that val will be 11 at the end, but in the third one, num got 11 after the decrement, and in the last one, num got 12 before the decrement. Okay, so tiny little difference there, but that is available, and that tiny little difference does get used in code to be very careful about when you're incrementing or decrementing your variable. Okay, now remember, the point of this lecture is about while loops. And in all of our loop structures, we frequently use these increment decrement operators to keep count, really, is what you're going to see here, of how many times the loop is happening. So let's dig into the while loop. Yeah, the while loop. Looks like this. You're going to see the keyword while. You're going to see parentheses for a Boolean expression, and then you're going to see a controlled statement. Looks a lot like an if statement, right? But has a very different effect. So this is what allows a statement to be repeated. When the expression is true, the controlled statement is run, is executed, and then, right, so far that's like an if statement, but at the end of that, then the program jumps back up to the while and it checks in again, right? And it keeps doing that. Now, when the expression is false, then the controlled statement is jumped over, like an if statement, and the program flow continues like normal from that point on. The loop has ended and you just go on with the rest of the program. Now, remember that statement there, and a lot of people call that the body of the loop, right? The first line is the head of the loop, and the rest of it's the body of the loop, the thing that actually happens. So I've written just one statement here, but again, if you want a whole bunch of statements, you can package it up in curly braces, in a block, and then that really counts as one single controlled statement, again, the body of the loop. Don't forget that for any kind of controlled statements, you get one more tab indent, as always, right? Just like an if statement, just like a switch. So that is what that looks like. Again, for some of my students in the past, if they see what's the difference between this and if statement, and the key is once the statement is run, you go back and you do it again. Pretty powerful. Okay, so let's see an example of that. Looking at this in flowchart form, you have a program that's doing some stuff, doing some stuff, doing some stuff. You get to the while statement, checks in on that Boolean expression as a decision, and if it's true, then you go run those statements in the body, and then you go back. You go back right before the while statement, right? And then you run into that expression again and you check it again. If it's false, you go on with the rest of the program. If you compare this flowchart for the flowchart for if in chapter 4, right, the primary difference is this arrow coming out of the statement. Instead of going before the test, for an if statement, it comes out after the test. Right, so basically the difference is where is this arrow coming out of statement. For a while loop, it comes out before the test, so it repeats. For an if statement, it comes out after. So maybe you're skipping something. And let's see the actual code for this. So this is program 5.3 in the book, and this is our first example demonstrating a simple while loop. Just a couple lines here. Line 7, we're making an integer called number and initializing it to 0. That's going to be our counter for how many times the loop has happened. This particular loop that we're seeing is set up as what's called a count-controlled loop. Then on line 9, you see the while statement, and the expression here is your number less than 5? If that's true, you'll go into the body of the loop. You notice that this is two statements in curly braces, right? The body starts at line 10, ends at line 13. There's actually two statements in here. So assuming number is less than 5, you'll go to line 11, you'll print out hello and a new line, right, a line break on the screen, and then you go to line 12, and you see number plus plus, right, there's that increment there, which will make number become 1 more. So the first time you go through this, number will become 1. And then you'll go back to line 9 again, right? And it'll check in, is number less than 5? Well, if number is 1, that's true, so you'll go into the body again. You'll print hello, you'll come to line 12, and number will get incremented to 2 now, right? Indicating that we've gone through the body of the loop 2 times. And as that increases, right, you do it again, you do it again, you do it again, and at some point number becomes 5. So when you check in on line 9, is 5 less than 5? That's false. And at that point, you'll skip over the body of the loop, you'll land on line 14, and you'll print out, that's all, and then the program ends. So let's test this example of a count-controlled loop, this first while loop we've seen. I've pulled up program 5.3 out of the book here, so I can compile it. That looks good. I'll close the compile log here, and I'll run it. Great, and it's done. Okay, so the point of this program is to print hello to the screen, and you can see that's 1, 2, 3, 4, 5 times, then print that's all. Exactly. Okay. You know, what could we do to this program to print hello, 10 times? Okay, so hopefully you can guess that all you have to do is just go into line 9 and change that boundary condition there from 5 to 10. So I'll recompile it because I made it change the code. Great. And then I'll run this, and now the program's printed hello 10 times. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then that's all, of course. Right? What if I want it to print hello 500 times? Okay, I'm just going to go in here, and instead of a line break here, I'm going to make it a space instead. No problem, right? Just change this here to 500, and try that. And okay, so before I could get my console on the screen, there's 500 hellos that it printed. I can scroll up and scroll up and scroll up, and pretty much faster than I could see it, it very easily printed 500 hellos to the screen. I'm kind of scrolling around here. What if I wanted 50,000 hellos? Right? No problem, right? Tiny little program. We'll totally be happy to do this. Let me run this and see if I can get the console on screen before it finishes. Okay, so it's printing and printing and printing and printing. Still printing. Okay, so it has successfully printed 50,000 hellos to the screen, and then that's all. And you can see that on my system, it took just about 4 seconds. It took just about 4 seconds to print 50,000 hellos to the screen. So this is what Alan Perlis meant when he said that a program without a loop isn't really worth writing. This is the first time that I'm getting to really use the speed and the power of my processor to do thousands and thousands of things in a single second, right? So that's a pretty good example of that. And again, you want it to do it, try it on your own if you wanted to see it do it, 100,000 times or 1,000,000 times or 4,000,000 times. No problem, right? That's what the computer is for, is to do some very simple, well-defined task at insane speeds, is what it's for. But as usual, let me just flip this back to the way it started. As usual, maybe you can guess what I'm going to do next. When I see a new control structure, I like to step through in the debugger and be really, really aware of exactly what's happening. So let me do that here. Give myself a little bit more space. I'll put a breakpoint here on this first line, and I guess I have to recompile it because I just made a change. And then I should be able to debug it. Okay, so bring my console on screen. So as usual, the program is now running, but the debugger has paused it just before that assignment, that initialization on line 7 happens. And I want to keep track of what's in number, actually. So I'm going to add a watch for number. And you can see over here in the debug tab, as usual, as the program starts up, right, line 7 hasn't happened yet, the variable location for number is holding some random garbage. And this particular case, what is that, 9,316,684? Could have been anything, could have been positive, could have been negative, sometimes 0. No way you can depend on that. I was helping a student earlier today, and they were a little foggy on this issue, and they had uninitialized data, and which is very risky because then that would get into their calculations, and their program was likely to not work right. Now, on the other hand, you might get lucky, and it just might possibly start out with the number you needed, maybe, but you're going to be very unhappy when somebody else takes it and runs your program in a different context. Anyway, you knew that, right? So I'll hit next line, and line 7 will happen, and you'll see the 0 go into number. Great. Okay, so 0. So number now has 0. So here's line 9 happening, and you're going to check in on, is number less than 5? And so when I'm in person classes, I usually use this as an opportunity to quiz my students. What line are we going to go to next? Okay, so hopefully this first one's pretty easy. So if the while expression is true, you're going to go into the body of the loop, and the first thing in the body of the loop is line 11. So next line, great, I'm on line 11. And when we run line 11, obviously, it's going to print hello to the console. And what line will we go to next? Well, line 12, that's the normal thing we do. If you're on line 11, the next thing is line 12 unless something special is happening. So let's see that happen. So we printed hello on the screen. Now we're on line 12, and when I hit next line, right, that's going to increment number. Number will become 1 now. And what line will we go to next? Well, line 9, right? That's the whole point of the while loop, is you run the body, and every time you run the body, you're going to come back to the while statement. So line 12 just made number increment up to 1, and we went back to line 9. Okay, so what does line 9 do? Well, it checks in on whether number is less than 5. That is true right now. 1 is less than 5. So we'll go into the body, line 11, right? That prints hello. Line 12, that's going to increment number up to 2. And here we are at the end of the body. Then we'll go back to the while loop, back on line 9, right? And at this point, we've now printed hello twice, and the number counter is holding 2, right? It holds the number of times the loops happened so far. And checks in again. 2 is less than 5, so you'll do the body again, right? Number is currently 3. 3 is less than 5, so you'll do the body again. Come back. Number's 4 right now. Okay, so yeah, 4 is less than 5. So you go into the body, you print hello. Okay, you're on line 12. Line 12 is about to happen. I think we agree that number's about to become 5. And then the question is, what line will we go to next? Let's see. Well, you go back to 9. You always go back to 9. When you get to the end, if you're doing the body of the loop, right, you always go back to the loop statement. No question about it. So number has become 5. We're back on line 9. You check in on that expression. Is 5 less than 5? Well, that's false. So where are we going to go now? Let's see. I'm on line 9 right now, and next I'm going to be on line 14. Again, when the expression becomes false, then you skip over the body, and now you're going to go on with the rest of the program. So here I'm on line 14, and obviously that prints out that's all. Right? And then you return 0 back to Windows to say there were no errors, and then it's going to get cleaned up and the program's going to end. Right? So hopefully that's kind of helpful to see that. Now I will highlight that we started number at 0, and hopefully that kind of echoes starting counting by 0 like we do in computing a lot. We saw that with place values, right? So any kind of place value system, the smallest, the first place value is something to the 0 power. And that's how you get 1 for your ones place, for the smallest place is just when you're constructing a number. So here we are starting our count at 0, which makes sense because before the loop happens, it's happened 0 times, right? So if this is keeping count of how many times has it happened, it ought to start at 0. We usually do that for our count controlled loops. It doesn't have to be that way, but usually we start at 0 and our test is, are we still less than the number of things that you want, right? Other ways of doing it, but this is probably the most common, so kind of keep that in mind. Okay, so loops are powerful. They are what make your programs worth writing, finally, I guess. But with power comes a great responsibility. There's a couple of risks in loops, and if things go wrong, you can have a really bad problem, actually. The main problem with loops is if you bungle how they're written, you'll get what's called an infinite loop, where the Boolean never becomes false, and therefore the loop never ends. And that processor is just stuck doing this loop forever. Until your operating system, terminates the program, or you Control-Alt-Delete or something like that. So if the while expression never becomes false, which is probably a big mistake, then the loop will just happen indefinitely. The program will not halt on its own, and it's going to look like the computing system has become unresponsive. It won't take input if that's not in the loop. The computing system might just lock up and now nothing's happening at all. On older systems, right, when I started programming on older systems, I might have to reboot the computer because just nothing is taking input anymore because I'm stuck in this infinite loop. Now on modern operating systems, you'll be able to cancel that program pretty easily. But still, beware of infinite loops. If your program is running and just locks up and it stops responding, my first guess is probably an infinite loop. And I start to go looking in the code at where the loop structure is and trying to detect some kind of problem. Let's look at some examples of that so you're aware of what might go wrong. So I have two examples here, right? These look very similar to program 5.3, our first count control loop. Can you spot what's different? Right? Can you maybe pause the video, and can you spot what's different from the program before? What would cause an infinite loop here, and what would you do to fix it? Do you think you know? We should check. Okay, so I brought back up program 5.3, and I'm just going to edit this to match the mistakes on the slide that had examples of infinite loops. So if you look really carefully, the first example was that line 12 wasn't there, right? Line 12, where the increment is, got deleted, probably by accident. So if I compile this, it compiles, it runs, and let's see what happens. Okay, so it's printing, I don't know if you can see this at the bottom, so it's printing another hello and printing another hello and printing another hello, and it's printing an infinite number of hellos is what's happening right now. So and obviously the reason for that, it should be pretty clear, is number started at 0, right? You got the line 9 is 0 less than 5, yes. So when you go into the body, you print hello, you come back to line 9, but number's still 0, right? And it says is 0 less than 5, well, I'll do it again. And number will still be 0. So without the increment, number never changes, and you just forever are testing is 0 less than 5, is 0 less than 5, is 0 less than 5, and it winds up doing this forever, right? So my program here, it won't take input, right? It won't ever stop doing this, and I just have to take control in Windows and close the console. For what it's worth, if you go to your task manager and you look at your processor usage, one of your processors is going to be 100% being used by this loop that's just printing an infinite number of hellos. So I don't really want that to happen, so I'm going to cancel this. Okay, so that was the first error. Now, the second example of an infinite loop is even more subtle than that, and I don't know if you caught where the difference is. The difference is right here. The second example has a semicolon at the end of the while statement before you get into the body. I see this as a common mistake among beginning programmers, and you can see how it's so simple to do. But remember, a statement ends at a semicolon. So what's going to happen here is you'll get to line 9, okay, 0 is less than 5, the end. That's the end of the while statement right there. And right there, it's going to go back to the beginning of the while statement, the beginning of line 9. And it's going to say, oh, you want me to do it again because 0 is less than 5? Okay, great. Now I'll go back to line 9. You never actually get out of line 9. You just get the end of line 9 to the back to the beginning of line 9. The end of line 9 back to the beginning of line 9. You never even get to line 11 or 12. Okay, so what's going to happen here if I compile this is, and you can see I've actually got a warning in my compiler. I have my warning settings really high. You might not actually see that warning if you do this, but it says this while clause does not guard any useful body. I think if I dig into that is what it's saying. But this will compile. It's technically legitimate C++. And then when I run this, it looks like it's doing nothing at all, right? That's kind of tricky because this just looks like it's doing nothing. But the truth is it's caught in an infinite loop, just doing line 9 over and over and over and over again, never getting to the printing statement. So once again, this is unresponsive. I can't put any input to it. It's using up 100% of one of my processors right now to do literally nothing. And that's another example of an infinite loop that's even a little bit trickier. So if your program does that, it locks up and doesn't even do anything in the body. Look and see if you don't have that broken semicolon at the end of your while line. And I'm going to have to cancel this. That semicolon right there, that's the end of the while. Without it, the end of the while is this curly brace down here. And that's usually what you want. Okay, so that's a pretty good introduction to while loops, actually. They're kind of the basic way of getting something to repeat in a C++ program. So you're finally getting some real power with the computer processor. You now might be confronting some risks like infinite loops that would just lock up your program and have it stop doing anything ever again. So getting more practice with this is good. And at this point, for my classes, we would get together and we would do this first lab working with the while loop. And so the example that we saw in the lecture here, program 5.3, was a count-controlled loop. There was an integer, right, number, keeping track of how many times the loop happened. And we knew in advance exactly how many times it was going to happen, right? If my loop said, keep going while number is less than 5, the loop is going to happen exactly 5 times. You know that in advance. That's not the only way you can set up a loop. You can have what's called a user-controlled loop, and that's actually what happens in this lab here. So in this lab, you get the user to type in some kind of input, and then that gets echoed, repeated to the screen, and then they get asked for another piece of input, and they get asked for another piece of input, and that repeats and repeats and repeats until the user types in some particular value that finally cancels the loop. Some of us would call that a sentinel value, like the specific magic number that you have to type in to stop the loop. So in this case, you're not going to be able to predict in advance how many times the while loop happens because it's in the control of the user. But we use this technique, sometimes quite a bit for data entry and stuff like that. So pretty good lab. If you have access to the lab code on your own, try this. It's very short, but it's a pretty good second example of something that's not count controlled, but user controlled, but they're both while loops. So that's pretty good. Now remember, while is the first of the 3 options for loops in C++, and all this stuff is exactly the same in C and exactly the same in Java and so forth. So in our next video, we'll look at option number 2, which is the do while loop, and how it's a little bit different and situations that you'd want to use that for actually. So I'll see you then.